Hi everyone and welcome. Let's learn how to solve linear programming problems using the solver add-in tool in Excel. So let's consider this problem. A candidate for governor has allocated $20,000 for last-minute advertising in the days preceding the election. His campaign manager wants to use two types of ads, radio and television. Each radio ad costs $100 and reaches an estimated 1,500 people. Each television ad costs $250 and reaches an estimated 3,500 people. So the campaigning governor would like to reach as many people as possible, but he has stipulated that at least 20 ads of each type to be used. Also, the number of radio ads must be at least as great as the number of TV ads. So the question is, how many ads of each type should be used to reach a maximum number of people? So to solve this problem, you need to outline three things. You need to know the decision variables in this question. You need to know the objective, and you also need to have the constraints. In this case, the objective of this function is to maximize the number of people reached. So the objective function will look like this. The objective function will actually look like this. The number of people reached will be equal to 1,500 multiplied by the number of ads plus 3,500 multiplied by the number of TV ads. So here, these are the decision variables. The number of radio ads these are the decision variables. You can use dummy numbers just to make sure the spreadsheet, to improve the functionality of the spreadsheet. So let's, for example, use a dummy number like 23 here and 20 here. So once you have the dummy numbers put in place, and then you have 1,500 here represents the number of people reached, the estimated number of people reached for the radio ads, and 3,500 the number of people reached for the TV ads. So you have to create now a formula for the objective function. So to do that, you're going to use the sum product function, and then select the decision variables here, comma, and that array as well, then hit enter. So this is actually the formula for the objective function. It's just the same as 23, that is the number of ads multiplied by 1,500 people, plus 20 multiplied by 3,500. And now you have the formula for the objective function. Moving on to the constant table, you'll have to create a table, then include the left hand side, the sign, and then the right hand side. So the first constraint is this: 100R plus 250R should be less than or equal to 2,000. Take the coefficients of the R. R here represents the number of radio ads, and T represents the number of TV ads. 100 the coefficient here, 250 the coefficient of it you put here, and then the sign, which is less than or equal to, here you put it here, and then the 20,000, which is the constraint, you put it here. Moving on to the second constraint, we are told that at least 20 radio ads should be used. That is, R plus 0 T should be greater than or equal to 20. So the coefficient of R is 1, the coefficient of T is 0, the sign is greater than or equal to. So you do the same for this constraint and for this constraint. And then now, coming on to this left hand side column, you need to input a formula. So in this case, we're going to use the sum product formula as well. You select this array, R&T, so you select this here, comma, and then this array here, then close the bracket and then hit enter. So it's like you're just taking 100 times 23 plus 250 plus 20 to give you that formula. So to drag this formula down, you need to lock these two cells. You need to lock these two cells so that you can drag that formula. So you add that dollar sign. You add the dollar sign there. You also add another dollar sign here and another dollar sign here to lock this cell. And then now hit enter. Then now from there you can drag it down to copy the formula down to the rest of the columns, so that when you hit here using the same product function, where we are taking this number multiplied by this plus this number multiplied by this, and then you get that answer. Then from there, now we can now go direct to the data tab, then look for the solver add-in. You're told that what if analysis tool that finds, it's a what if analysis tool that finds the optimal value of a target cell by changing values in cells used to calculate the target cell. Solver is found in the data tab, and if you have not loaded it in your Excel, check my other video on how to load it in Excel. The link is in the description below. So in this case here, you need to set the objective. In this case, we want to maximize the number of people reached. So this is the cell that we want to maximize. So you select it as the objective. The option you choose here is to maximize. Then which cell variables do you want to be changing? So by changing what cell variables, so you select the cell variables that you want to be changing, which are the decision variables. And then in the subject to what constraints, we have the constraints here. So you click on add. So the cell reference will take this part, the LH, the LHS, then the sign will go for this, and then constraints will go with RHS. So the cell reference here is this, the sign is less than or equal to, you just leave it like that, and then the constraint is 20,000. Then you click add again, select this cell, then the sign is greater than or equal to, and then the constraint is 20. Click add again, cell reference 20, sign greater than or equal to, and then constraint 20. Then add the fourth constraint, this cell here, then the sign is greater than or equal to, then the constraint is 0. Then you hit OK. You can counter check this to make sure you put in the right constraints, and then this has to be, you have to check this, make unconstrained variables non-negative. That's okay. And then you have to go ahead and select simplex LP, simplex linear programming, then hit solve. Let it load to give you the answer. Yes, so these are the solver results. Solver found a solution. All constraints and optimality conditions are satisfied. So of course you're gonna keep the solver solution. So you hit OK. So now these are the solutions that solver has found. That we can maximize the number of people reached to 295,000 people. This is 295,000 people are the maximum number of people that we can reach. By doing what? By purchasing 150 radio ads and 20 TV ads, given all of these constraints. So the summary sentence will say that you will advise the candidate for governor, to purchase 150 radio ads and 20 TV ads to reach a maximum of 295,000 people. Thank you for watching. Please subscribe.